Hi, everybody. This is a short explainer video for day 3 of the programming bootcamp. Let's go to GitHub, look at the Jupyter notebook for day 3 of the bootcamp. It is very possible that by the time that you actually use this notebook, it will look slightly different, just with a bit of different formatting potentially, and perhaps some typo fixes. But still, the content is here. So day 3 is about functions and a bit more. So we've already seen inbuilt functions like print and len and other functions, but we can define our own. So a function is something that does something or computes something. In mathematics, we have pure functions. They have inputs and outputs. In computers, we also have pure functions, but they can also do some change to the system, such as, for example, print something on your screen, but not necessarily. Okay, so we'll define our own function. For example, here, this is how we define a function. The function has an argument, and it does x squared plus 1, and that function is called square and increment. Great. So we know how to work with a basic function. That's good. Functions can also have 2 arguments or more, and here the function does what it does. Okay, and you can even have functions that do other things, etc., etc. So we have functions. Now, the instructors and the tutors will discuss more about why functions are good and how programs can be broken into functions and how functions allow you to abstract things, etc., etc. So your first task is to actually write a function that takes a list of numbers and returns their arithmetic mean, their average. It's going to sum the things up and divide by the length. Okay, that's going to be that task. Now, a function can also call itself. Okay, so calling a function means applying the function, using the function. So the most basic classic example is a factorial function. So this is a recursive call of the factorial function, and you'll investigate that in the meetup. The second task is to write a recursive version of the callout sequence until hitting 1, each time printing the value as well. So the way that function works is it says, okay, if the value is 1, then I just return. Otherwise, I am going to compute either the number divided by 2 and return that number, or 3 times the number plus 1 if it's even. Maybe I got that wrong, the odd and even. Okay. Now, functions can return multiple values. The mechanism for doing that is using a tuple. We've already seen tuples, and functions can have a return value, which is a tuple, and that's how a function can return multiple things in the same time. Okay, so we play a bit here with tuples. We see that tuples are immutable in contrast to lists, and that will be discussed. So here's a function that actually takes a quadratic equation parameterized by the coefficients of the second degree of polynomial, right? Ax squared plus bx plus c, and computes a discriminant and either returns an empty tuple or a tuple of length 1. This is how you do a tuple of length 1 or a tuple of length 2, which has the solutions, the real solutions of this equation. And this is another function that takes the coefficients and the potential solutions and checks if they're really solutions. And here you'll spend a while discussing and playing with a few more examples that the tutors will show of lambda functions, which are in a sense anonymous functions defined right here. That's a bit of a cool thing in Python. Other languages have this too. Okay, so we can check that the quadratic equation function actually gives us the roots. Okay, and that's what you're going to do here. So this next task is going to be to write a function that gets a list of numbers and returns a sample mean and sample standard deviation. So it's going to return a tuple with sample mean, sample standard deviation. Sample standard deviation is in essence, it's the sample mean of the deviations from the sample mean squared. Only the mean is typically divided by n minus 1, the number of observations minus 1, not n. That's a small issue. That's not so important. Now, here's a function that checks if all the elements of a string are in lowercase. So you'll try to understand how this works. This works because the ASCII code of numbers are ordered. So everything between capital A and capital Z has some order. So you'll use the ORD function, which returns the ASCII or uniform number of a string. And this is how you document the function. This is how you can do help on the function. Okay. And here you'll just make a variation of that, which is please write a function that checks if all characters in a string are letters, either uppercase and lowercase. So it tells you, for example, if you have an exclamation mark, it says up, not allowed. Or if you have a number or a space, not allowed. Okay. Then we'll discuss variable scope. So the scope of a variable is where variables live, and we'll see through this example that, for example, here A lives in global scope, and this is a local A, which is not this A. So this changing of A does not change the global A. However, if a function wants to deal with something that is global, you mark it as global as follows. Okay, so you say global A, and that deals with global variables. And the instructors will also discuss why global variables in big programs cause some trouble, etc., and should generally be avoided. Okay. Now here's a function which defines the density or the probability density function of a normal distribution, pretty much the bell curve. That's the mathematical function of that. You probably know this from some other courses. So e to the minus x squared is the main thing that you have, e to the minus x squared, but then you also have shifting by the mean mu and the standard deviation sigma. But what we see here from Python perspective is for the first time that we use some named arguments and they have default values. So if you just do normal density on x, you have your standard normal with mean mu and sigma 1, but you could also have others. Now, we won't do this much in the bootcamp, but in this case, we're actually going to use a plotting library, which you would use a lot in many other courses. Okay, matplotlib. And we also use NumPy, which actually enables Python to have arrays, not lists. So arrays are continuous lists of the same type, typically floats in most cases. Okay, and that's good for numerical computing. And that's just for making these two plots of the density. So the normal density, which is standard, and the normal density with a slightly wider sigma. Okay. And then your task is to write a function that actually sees that the area under both of these curves is approximately 1. So the integral of these functions will be approximately 1, and you'll do that by looping and doing a Riemann sum, or Riemannian sum, just rectangular bits, each one of width delta, and you'll sum over x's here. Okay. That's this exercise. So then we'll go and we'll discuss lists for a while. So we've already worked with lists, but we'll discuss lists a bit more. Okay. And we'll see that lists are actually mutable. They're not immutable. So we'll see the situation where you have one list which can point at something in memory, and one list which can point at something in memory, and then a different reference to a list, to different variables, your data, which equals my data, which says, hey, that also equals my list. Now I'm going to change the last element of your data to be 100. And then I look at my data and actually change this 23 to be 100. So there's a big discussion to be had there with actually what variables really mean in Python. And in this case, because lists are mutable, we actually changed both my data and your data point to the same list. And that's important to keep in mind also within the context of functions, even though it's not in this example. So let's say we do not want this behavior. A way to work around this would be with the copy method. Okay, so this type of notation we haven't seen much. Well, we've seen a bit of it here. And that's, well, like this dot here, etc. And that's object-oriented notation, which says the copy method of the myData class, and that class is a list. And the instructors will speak about that. And we use those from time to time. And that's really what later in a more advanced course, if you actually create classes in Python, then this is what you do. But that all this is side comment. Basically, we just want to create a copy of my data. Okay. And here's a big task, and you'll think and discuss how to do sorting. It doesn't have to be in a very efficient way, but in one way or another. So you'll want to write a function that gets a list and returns a sorted version of that list. And then will come the discussion, hey, are you actually going to modify the list, or are you going to create a copy of the list? How are you going to sort? Well, the simplest way is maybe look for the smallest element and then look for the second smallest, so look for the third smallest. That's maybe one way. That's not the most efficient way, but it will work. And we'll see all kinds of functions for lists, such as append, and we'll see the fact that we can concatenate lists just like we do with strings. Okay, we'll see the in operator, which checks if an element is in a list or in another collection. That's very useful. Okay, then in this task, you're asked to write a function that loops, okay, asks the user for names of friends and their phone numbers until you say stop. And then it returns a list, a tuple, where one is a list of names, one is a list of phone numbers. So for example, the return value can be something like this. Okay, so that means that Kaylee has this phone number, Emily has this phone number, and Miriam has this phone number, for example. Now, another task is to write a function that gets a result like this, and a name, and return the phone number associated with that, or nothing if there's no, if we look, if this result is going to be like Jacob, well, there's no Jacob not found. Now, this is all motivation for a different data structure that's extremely powerful, and this is how you specify a static version of it, and that is a dictionary. Okay, so this thing is a dictionary. It actually, we don't see the word dictionary here on the screen, but this is what it is, dictionary. And then you can index dictionary by Kaylee, and you get this. Okay, dictionaries have keys, and dictionaries have values. Dictionaries are not ordered, and you can add to the dictionary. Here's a new friend. You can also try to query the dictionary and say, hey, if the key is not found, then you get an error. Okay. And here's a printout of the dictionary. You can delete from the dictionary. So dictionaries are powerful, and you'll also read a bit about data structures coming inbuilt with Python, such as lists and dictionaries and sets here. Okay, now Python also has sets. A set is just like a dictionary without values, just keys. And this task is to create, so sets don't have an order, right? And elements are unique. So try to create a set with the list as an element, and you'll see that that won't work. And then you'll have a discussion about why that doesn't work. Okay, then comes this task, which is a bit of a big task. So in this task, you'll assume that you have some data structure, which is assumed to be of this format. So it's a dictionary indexed by keys that are names, so kind of like a contact table, okay? And each name in its own right also has a dictionary, which is the data associated with Ben. Ben has a phone number, an email, and age. Interestingly, Ben also has friends, and there's a list of the friends of Ben, okay? So, of course, in a real setup, you might use something like a SQL database for doing this, not a nested dictionary of dictionaries. But this is also actually possible with something called hierarchical databases to have this like this. But it's quite a nice way to structure things, and you'll play with them. So in 310A, the last task of the week, you write a function that checks consistency between friends. For example, if you get a data like this as input to the function needs to check that every friend of Ben is also Ben is also a friend of him, okay, or her, okay, or them. So you see Beth has a friend Ben, and Ben has a friend Beth. So that seems consistent. Jacob, well, Jacob, even though Beth and Ben think that Jacob's friend, Jacob doesn't have friends. Friends is an empty set. Okay, so that I'm happy here. Okay, so that would be false. Okay, and then you'll write a function that gets this type of thing and adds a new entry. So kind of like add to entry. Okay, and then you'll write a function that deletes an entry. But as it does that, say now we delete Jacob, okay? So we would need to also go and delete Jacob from here and delete Jacob from here. So this is just an example of some logic of how to go through not the simplest data structure, but a quite powerful data structure, which in this case is a dictionary where the keys are themselves assumed to be dictionary, and the last key of the inside dictionary is actually assumed to be a set. By the way, I think this is probably a mistake because this is, I think, an empty dictionary, not an empty set. So we should have written set here, not dictionary. But that's not a big deal. Okay, so that was day 3, and that would be the end of the first week. You might not finish all the tasks by the end of the first week. You might choose to skip some of them. You might want to do them all, do them over the weekend, leave some of them for the next week, ask, communicate. You're the boss. Okay, anyway, enjoy.